Okay guys, welcome to the second courseware in Python programming. So today in this course we would be starting from a new chapter which is known as Abstraction, and this chapter would be the Abstraction part 1. So in this chapter we will learn how to group statements into functions, and which enables us to tell the computer how to do something and to tell it only once. So we won't have to give it the same detailed instructions over and over again. This chapter will provide a thorough introduction to parameters and scoping, and you will learn what recursion is and what it can do for your programs, and we will also see how functions themselves can be used as parameters, just like numbers, strings, and objects. So I'll just start with the first topic in the abstraction. So before I go ahead and proceed, I'd like to tell you a famous thought, which is English proverb. So it's called as a laziness is a virtue. And we all programmers over here, we are lazy. That is the reason we want to make a program that does our day-to-day things. We want something to be so compact that we want to write very less of the codes, and if we want the programs to go ahead and do much more things. Is that possible? Yes, it is, and that's the reason we are learning programming over here. So the programs we have written so far in the previous course were pretty small, but that was just for the beginners. But if we want to make something bigger, we will soon run into trouble. So consider what will happen if we have written some code in one place and we need to use the same code in another place as well. But the modules that we used in the first course, in the first place, were different, and the second place we don't have the same modules. We would have to write them down all over again. So let's say, for example, we have written a small piece of code. Let's say, for example, Fibonacci numbers. So first of all, Fibonacci numbers are a series of numbers in which each number is the sum of the two previous one. Let me first explain to you in detail what Fibonacci numbers are. So I have my notepad over here. So let's say, for example, the first number is 1, second number is 2, If the first number is 0, second number is 1, and the third number would again be 1. That's how Fibonacci numbers is, because 0 plus 1 becomes 1, and the next number would be 1 plus 1 becomes 2, then 2 plus 1 becomes 3, then 3 plus 2 becomes 5. So like this it goes on. Next number would be 8, after that it would be say 13, and after that it would be 21. So that's how Fibonacci numbers are. They are the sum of the previous two numbers. So now you know what Fibonacci numbers are. Let's go ahead and write one in our simple interpreter. Let me just delete this. So I'll just go ahead and write a Fibonacci number. Let me give it a name, a variable. Let's say fibs, F-I-B-S, as Fibonacci. And I'll just write it as 0 and 1, the start two words, that the starting two numbers that I need to put, because it needs to calculate the first two numbers, and only then it can go ahead and calculate the rest of the numbers. Now just go ahead and use the for loop for I in range. Let's say I want to calculate a total of 8 Fibonacci numbers. I'll just write this, colon, enter, then indentation, 1, 2, 3, 4, and then fibs period append, that means add, and I'll just write fibs bracket -2 plus fibs bracket -1, and the end of parentheses. Now when I go ahead and type fibs and enter, it will give me all the numbers that it has calculated. So what this program has done over here is that it has just calculated the previous two numbers. So let's say the index of the first number would be 1 and 0 and 1. So 0 and 1, it's 1 again, so that's why it's 1. So this means this -2 means the number -2 plus the index of the that number -1. So that means this -2, that becomes this one, and this -1 becomes this one. So the total of this is this. Then again for 2, index of -2, that means this becomes -2 and this becomes -1, that becomes 2. For 3, index of -2 and index of -1, that becomes 3. So till that it goes on until it has calculated total a range of 8. So after running this, the Fibonacci contains the first 10 numbers. And you must be thinking that if I have written over 8 over here, then why it has 10 numbers? The reason being that it has calculated 8 Fibonacci numbers, and the first two numbers were provided by us. It did not calculate that by itself. So this is alright if we want to calculate just the first 10 Fibonacci numbers only once. We could even change the for loop to work with the dynamic range with the length of the resulting sequence supplied by the user. So now we know what Fibonacci numbers are and how we can go ahead and calculate them. But what if we want to use the numbers for something else? We could certainly just loop and write the same loop again and again when needed. But what if we had just written a more complicated piece of code? For example, let's say I have downloaded one piece of code and I just want to use the same code again and again, but I don't want to write down the same code again and again. That means I have written one code down, it's a big piece of code, but I don't want to write that again and again. I just want to compile it into one single small code and I can use that as a module. So I'll tell you one more thing, real programmers are lazy. They do not go ahead and write down the full program again and again and again. But that sense it means that they don't do any unnecessary work. They are very much intelligent and they write down one piece of code, they compile it and they use it whenever it's needed for any other code. So here only what is specific to a program is written concretely. Actually, computing the Fibonacci numbers is done in an abstract manner. We can simply tell the computer to do it, but we don't say specifically how it should be done. We create a function called fibs and we can use it whenever we need, and we can use the functionality of the Fibonacci program. It saves our effort and a lot of effort when needed in several places. So that's called as an abstraction. That means that we can go ahead and write down this whole program of Fibonacci numbers inside one module and we can convert that into a function itself. So when we want to go ahead and call that specific function, we just call that specific function. It will calculate everything. We don't need to write the whole code down. So this is called as abstraction. Abstraction can be very useful and as a labor saver, but it is actually more important than that. It is a key to making computer programs understandable to humans. But that's not the only case. And making the computer program understandable to humans are essential, whether we are writing or reading them. And the computer themselves are perfectly happy with the concrete and specific instructions. But we humans generally aren't. So if you ask me, let's say for directions to go to a specific place, let's say for a cinema hall, then for example, I'll just go ahead and give you an answer like this. Walk down the street until you cross the bridge and the cinema will be to your left. But if you go ahead and ask the computer the same question, it will give you an answer probably like this. Walk 10 steps forward, turn 90 degrees to your left, walk another 5 steps, turn 45 degrees to your right, walk 123 steps, let's say, and we would soon lose the track, won't we? Because the steps that we go ahead and take, it's different for different person. The step I take, mine would be 1. The same for a guy with a bigger height would be 2 steps maybe. So now instead of that, if I just go ahead and tell you that walk down the street until you cross the bridge, and once you cross the bridge the cinema is to your left, that would certainly be understandable to you, because we are not computers, because we don't need the exact instructions to go ahead and calculate, but computers do need that. And the point is that you already know how to go ahead and walk the street. I don't need to tell you how to walk that. And you also know how to cross the bridge. You don't need instructions on that, how to do that either. So the computer programs, computer structures, they work in a similar fashion. So by reading this, you can understand what the program does. However, you haven't explicitly said anything about how to do it. You just tell the computer, let's say for example, to download a complete page, web page, and compute the frequencies. The specifics of this operation will have to be written somewhere else, let's say in a separate function. And that's where creating functions comes in between.